grade 5, I hope you're well and welcome back to your natural science lesson today. Hope you had a lovely day so far and that you've managed to get some downtime from all the schoolwork, but I do hope you're attending your maths and English lessons as well. But we all know science is your favourite, so it's good. We won't tell those maths and English teachers. Yesterday we had a lovely fun lesson learning about some of the special qualities of metals, some metals that is, the fact that they have the ability to attract magnets, that's magnetism as a force, and we also looked at the fact that all metals are very good conductors of heat. And I did a couple of little demonstrations for you on screen, and hopefully you went home, you were already at home. Hopefully after the lesson, you did them yourselves. Maybe you had a fridge magnet lying around and you could test out which metals in your house were attracted to the magnets and which weren't. Or maybe you did the little experiment with the hot water and ice cold water in a jar and the 3 different types of spoons. Either way, I hope you learned something more. So today, let me minimize myself and get me into the bottom corner there. Today we are going to continue learning about matter and material. We're going to start by recapping some of your knowledge from grade 4 on the changes of state. And we are going to look today at reversible and irreversible changes. And that should then help us when we tomorrow look at how we produce materials through mixing and combining materials. Okay, so before I scoot on, just a reminder again of our website, email address. You're on the website. The email address is grade5@worksheetcloud.com, and there it is for you on the screen. Please remember to send any questions you have through there. So like I said, we're going to start today's lesson by quickly recapping some of the things that you should remember from grade 4. About changing states. Now remember, we say that all materials come in one of 3 states. They are either a solid, a liquid, or a gas. So let's see if you can remember some of the words that we use when we say something has changed from one state to the other. So in the middle here, I have a glass of water. And in order to turn that water into a gas, steam or water vapor, we say it has to boil. Okay, and the boiling points of there are different boiling points for different liquids. Hopefully you know that water boils at 100 degrees Celsius. Here on the other side, I have the glass of water turning into its solid form, which is ice. And we say that this process is called freezing. Again, liquids freeze at different temperatures. So if I had a glass of water and I cool it and I freeze it to become ice, in order to get back to water, I must apply heat for that ice to melt. Okay, so please, I'm just going over once again for you those very, very important words. But just remember, it's not only water that can change state. I can melt chocolate. So here I have a bar of solid chocolate and I apply the heat so that it melts into a liquid form. And then I can cool it so that it solidifies, there's a good word for you, solidifies into a solid form again. Here, considering we've been looking at metals, I have a solid piece of metal come straight from the ground, that's the metal ore, and if I heat it to the point where it becomes a liquid, now remember this won't happen at 100 degrees Celsius, this happens at much higher temperatures, and it becomes a liquid metal. It can be poured into a mold. It then is left to cool and it will solidify into a solid again, and this time I've made an arrowhead, or it might be a gold ring, whatever I want. And here is another example. So here I am going to create a fried egg for my breakfast. I crack open the egg and I have a liquid egg, but if I apply a heat from a metal frying pan that conducts heat quite nicely without melting, I create a solid in the form of my fried egg. Okay? Now, here again, I have a piece of bread. I want to make some toast. I put it in the toaster and the toaster heats it. Oh, have I got that one again? Do apologise, I shouldn't have that one again. Okay, here, now I have some milk, and if I heat the milk, I will separate with usually a bit of vinegar or an acid of some kind in the milk. I will separate the curds from the whey, and I can then produce cheese. So, those are examples of different changes of states. And I just want you to keep in mind the term reversible and irreversible. Keep those words in mind, reversible and irreversible. And it will give you a clue to this little activity I have on your screen. Have a little look at the activity. I've got a grid, and on the grid I have both columns. Columns go down and rows go across. And I would like you to spot in each column and each row the odd one out. Thinking about those words that I used a minute ago, reversible or irreversible. So if you'd like to, you can pause your video and have a little look and see if you can spot the odd one out in each row and each column. Okay, we'll come back to that in a second. So let's have a little look at our learning objectives today. By the end of this lesson, you should understand the difference between a chemical and a physical reaction and be able to give me examples of each. You should be able to make observations of a chemical reaction and name 3 things that indicate a chemical reaction has occurred. Now this should have been done with you in grade 4, but it's very important because, as I said, in the next lesson we're going to look at how we mix materials and combine materials to make new materials, and how we can have some materials that are processed materials from natural materials. And in order to do that, you have to know how states change and whether something is a physical or a chemical reaction, if it's reversible or irreversible. So let's have a quick look at the words that you have to know today. A physical reaction is a reaction that is reversible, and that means it can go back. So now if you think right the way back to the beginning of this lesson, when I started going through with you some examples of changing state, I showed you water freezing into ice and then melting again from ice back to water. That is an example of a physical reaction. It is reversible. I can go backwards. And a good way to think of that is if you're reversing a car. If your parents are driving and they reverse their car, they're going to go backwards. The opposite of that is a chemical reaction, and that is a reaction that is irreversible. And this means that it cannot be changed back. So think of that frying egg. I crack open the liquid egg and I fry it. I am never going to be able to get that egg back into its shell in a liquid form again. Don't get confused though. Something like chocolate, the chocolate example, that is actually a physical reaction. If I melt chocolate into a liquid and then I solidify it again by cooling it, it may not look exactly the same. The shape may be different, but it's still a physical reaction. No chemicals have changed. Nothing really different has happened to that actual item. But if I'm making a cake and I pour in some chocolate and some flour and some eggs and I mix it up and bake the cake, am I ever going to be able to get that chocolate out? No, that has chemically changed. And then the last two words are, the first is reactant. A reactant is the item that is being changed by the chemical reaction, and the word product. And the product is what is made from a chemical reaction. Now, you might have heard of the word product in maths when you're doing multiplication. Your teacher will ask you, what is the product? And it means you need 2 times 2 together. It's the same here in science. What is the product? What comes out at the end of the chemical reaction? Okay, so there's the new words to put into your vocabulary bank. Physical reaction, chemical reaction. Reversible, that's physical. And irreversible, that's chemical. A reactant and a product. So now let's come back to that odd one out and see if you could pick up the odd one out from each of the rows and columns, thinking about which of the pictures demonstrates a chemical, irreversible, remember, reaction, which show a physical change, which is a reversible one. Okay, so let's start on the top row. I have paper burning. I have got someone mixing salt with water, and I have a fried egg. So we've already gone over the fact the fried egg is an irreversible chemical change. But what about the salt with water? Now that is actually a physical change. I can, if I evaporated that water off, get back the salt, and I'd have the water in the form of water vapor that I could condense back into a liquid. So there's been no chemical reaction there. It's a physical one. Whereas the paper being burned, okay, the fire creates ash and soot from what was the paper. I'm never going to get it back. It's a chemical change. The middle row, melting ice lollies, a mouldy orange and a rusty nail. Well, the odd one out is the ice lolly, because that is a physical reaction. I can change that back by freezing the liquid that I get off those ice lollies. I will never be able to demold that orange and get it back to its original condition. And the rusty nail there, I can get rust off, but it will never be exactly the same. The nail will have lost its luster and it's actually corroded slightly. And then the row down the bottom here, I have a firework exploding, someone who has baked some cookies, and the rain cloud representing rain. So the one that is the odd one out, again, is the physical process of rain, because the water cycle, which you again should have learnt in grade 4, means that goes right the way back round, whereas these two are irreversible chemical changes. Okay, and if you look down the columns instead of the rows, then once again you should have picked out the physical reaction, the reversible, as the odd one out. So here, the melting ice lollies, here, the salt in the water, and here, the rain cloud. So now I'm going to do a quick demonstration with you of some chemical reactions. And I want you to take close observations of what occurs, and let's see if we can come up with a definite list to show and to think about if we are ever deciding if a chemical, remember that's an irreversible change, has occurred. So the 3 I'm going to do is I am going to light a match, I am going to mix some vinegar with some bicarbonate of soda, and I'm going to put a headache tablet, one of those dissolvable ones, into some water. Okay, so that's what I'm going to do. You may wish to now pause the video and draw yourself a little table like this, and on this side have what you observe from my demonstrations. So hopefully you can see me big now on your screen. I think I've done that right. But just in case I haven't, I will hold it up very close to the camera. So the first one is my match. Now please, I hope I don't need to say this to you, but please don't play with matches. If you want to see this in action for yourselves, ask your parents to do this for you. The last thing we need in lockdown is for you to have a house fire. Okay, so I'm going to light the match. And you should see it there on your screen, and I want you to observe what occurs. Okay, you can see. Don't worry, I will blow it out before it burns my finger. There we go. And there we go. I have some smoke now coming off, and the match has changed colour. Okay, so that was the first one. If you'd like to pause again, you can do so to write down your observations. Okay, the second one is I am going to mix some bicarbonate of soda, sorry, there we go, in with a little bit of vinegar here. I've got, you can't tell, it probably looks like water to you, but I do have some white vinegar in the bottom of this jar. So, do this. Okay, I'm gonna take a teaspoon and hold it up to the screen so you can see what happens. Ready? Remember, you should be observing and making notes on your observations. Woo! I just got a very wet, vinegary floor. Never mind, I'll clean that up later. At least it didn't go over my laptop. But yes, you can see there. That is the reaction we had. It's actually great fun to do if you go outside in the garden or on your patio or wherever, if you've got any outside space, and you can really make a big explosion. Okay, and the final chemical reaction, I have some headache tablets here, dissolvable ones, not like the hard panados. Those are not going to react. But here we go, I have headache tablet, and I have a second jar. This time it is filled with water, not vinegar, and I'm going to pop that in. Hold it up to the screen so you can see. And you can see there what's happening. If I left it for long enough, the entire tablet would go away. We would say it has dissolved. Right. So there you have it. You have seen 3 very quick demonstrations of chemical changes and hopefully written down what you observed in each. So let's take the time now to go over those observations together. Now here's what I have written down as my observations. Lighting a match. I said the match changed colour, it got hot, and smoke was given off. For the vinegar and bicarbonate of soda, I said it frothed up and fizzed. You may have said it was very explosive. It frothed up quite a bit, didn't it? In fact, just so you know, I actually use it quite a lot in cleaning. If you want to clean a sink that's blocked, I pour vinegar and put some bicarb down. And then a headache tablet in water, it fizzed and bubbled and eventually dissolved. Okay, so those are your observations from those 3 demonstrations of chemical changes. Now remember, those are the changes that are irreversible. So finally, as I said, our last objective for today would be to observe the changes and then come up with a list of at least 3 things that we can say happens when something irreversible occurs, when a chemical reaction occurs. So here, let's see if you can fill in my gaps. If there is a chemical reaction, one of the following things will happen. It will change. The will change. It fizzes, meaning a is given off, or there might be a different. Okay, so let's have a think. It changes colour. The first one is colour. And if I think back to the match, which I put down here somewhere, it changed colour. It went black, didn't it? Same with the match, the temperature changed. That's the second one. The temperature will change. It got hot. Not always hot. Sometimes it could get cold. It fizzes, meaning a gas is given off. That is both in the case of the bicarb and soda, or bicarb of soda and vinegar, or the headache tablet. Both of them fizzed, so both had a gas being given off. And lastly, there might be a different smell. So it could smell smoke. The vinegar changed in smell as well. Things start, it's just another piece of evidence that a chemical change has occurred. Now, for your homework activity, your activity to finish and recap everything we've spoken about this lesson, I have saved this worksheet with a memo for you so you can mark and check your answers on WorksheetCloud.com. I have changes, and it's basically a mind map. The arrows will lead you to a description, and you must think about what word fits in here. So let's do the first one together. Changes. These changes cannot be changed back once they happen. So there we have the word irreversible, or you could have chosen chemical. Okay? Or we could have these changes can be changed back once they happen. So this would be reversible or irreversible. And then you follow along. This is the change from a gas to a liquid. I know it's reversible and I'm changing a gas to a liquid. So I'm going to be condensing. Okay, so this is a lovely little activity for you to do. You hopefully should know all of the words because you should have covered them in grade 4 or in this lesson here. But as I say, the memo is attached so you can go and check your answers once you've given them a good shot. Okay, and that's the end of our lesson today. So I hope you've enjoyed it. I hope you learned and remembered a little bit more about irreversible and reversible changes. And I will recap it with you tomorrow before we start looking at how irreversible and reversible changes applies when we mix materials and we produce new materials through combining them. Okay, thanks grade 5 and have a lovely day. I'll see you tomorrow.